Okay, so on lesson 3.2, we're going to solve by elimination. So in 3.1, we reviewed solving by graphing and we reviewed solve by substitution. So by the end of this lesson, hopefully you can solve by using elimination with the different types of equations you might see. So let's start with the very basic. Both equations should be in standard form. That means the x and the y are on one side, you have a constant on the other. If that's the case, then you are ready to go with elimination. So let's look at this first example. You have x plus 2y equals 6 and x minus 2y equals negative 2. So to review, we have the x and the y on the same side. We have the x and the y on the same side. So we have it in the right form. If you don't have it in that form, then another method is probably going to help you. So you would want to go back and look at substitution or look at graphing. Okay, so then the next thing you want to look at is to see, do you have anything that's exactly the same but opposite signs? So if you look at this, these are both x's, but they're also both positive. So they're the same, but they're not opposite signs. So if we look at this, they are the same. They're both two y's, and one is positive and one is negative. That's what we want, because you are going to add down. So x plus x is 2x. 2y minus 2y is 0. And we don't actually have to write the 0. We know from doing other types of problems that that really means it just disappears. And then 6 plus a negative 2 is 4. Then we can go ahead and finish solving that. So 2x equals 4. Divide both sides by 2. So x is 2. Now you want to take this and you want to substitute what you just solved for back into one of the equations. And you get to pick the equation. So I'm going to pick this first equation right here. I'm going to say x plus 2y equals 6. And we are going to substitute this x equals 2 into this x right here. So this is going right here. 2 plus 2y equals 6. Subtract 2 from both sides. So we're going to go back up here now. 2y equals 4. Divide both sides by 2. Y equals 2. Now, I have an x and I have a y. The most important thing, well, not the most important thing, but an important thing to remember is this is really where two lines cross on the graph. This is a coordinate of where the intersection happens. So you want to always write the answer as a coordinate, x, comma, y. And so the actual solution to that is 2, comma 2. Okay, now sometimes when you look at a problem, you don't have two that are the same. So if we look here, we have a 2x and a 3x. Those aren't the same. We have a y and a 2y. Those are not the same. So we have to do something to one or both of the equations to make them the same. So I'm going to focus on this y column right here. You don't have to focus on y. You could focus on x. It doesn't matter. But if this were a negative 2y, then it would cancel. So how do I make that a negative 2y? I take the whole thing times a negative 2. So you are actually distributing across the equal sign. So you have negative 4x minus 2y equals a negative 46. And then we're going to just bring this next one over. We didn't change it, so 3x plus 2y equals 37. So now we have this right here. They are the same, which is what we wanted. Same with different signs. So now when we add down, negative 4 plus 3 is negative 1x. Negative 2y plus 2y is 0. And negative 46 plus 37 is negative 9. So divide both sides by negative 1, and x equals 9. Okay, so we know from before that that's only the first answer because we have to have an x and a y. So once again, you pick which one you want to substitute back into. I'm going to pick this one right here. So 3 times 9 plus 2y equals 37. So 3 times 9 is 27. Plus 2y equals 37. Subtract 27 from both sides, so 2y equals 10. Divide both sides by 2. Y equals 5. Now remember, we want to make sure that we write this as a coordinate, x, comma, y. So 9, 5. That is the point on the graph where those two lines would cross if you graph them. Okay, so let's look at this example. Let's check out the first one. Those are not the same. These are not the same. And I can't multiply any one thing to get the other. So this is a situation where we have to take them both times something. So I'm going to focus on the x this time simply because we focused on the y last time, and it doesn't really matter if I picked the y's, we would still get the right answer. So I have focused on the x's. That means I would need to take one of them times a positive and one of them times a negative. So if I took this times a negative 3, and this times a positive 4, now remember you have to distribute across the equal sign. So that's negative 12x minus 6y equals a negative 24. And we're going to distribute here. So that's a positive 12x plus 12y equals 36. Okay, so now we can add down. So this becomes 0. Negative 6 plus 12 is 6y. Negative 24 plus 36 is a positive 12. Divide both sides by 6. Y is 2. Now remember, we can pick either equation to substitute back into. So I'm going to pick this bottom equation right here. So I'm going to say 3x plus 3y equals 9, and I'm going to substitute into the y. So 3x plus 3 times 2 equals 9. 3x, plus 6 equals 9. Subtract 6 from both sides. 3x equals 3. Divide both sides by 3, x equals 1. Now remember, the answer is a coordinate, x, comma, y. Okay, so I only gave you 3 examples this time. So when you see a problem, you need to look at it and you need to determine, is it one where they already cancel, like the first one that we did in purple? Is it one where we would only have to multiply one thing by a number to get them to be opposites? Or is it a situation where we're going to have to multiply them both by something so that we can get some opposites that cancel? Okay, so on your practice problems, you just need to do the odds. And then when you get to the review, That's really sad. Okay, so that's supposed to say odds. Let's try that again. There we go. Nope, still bad. Okay. And then when you get to the review problems, complete all of them. Okay, so keep in mind, review problem number 13 has to be completed in class because it requires your graphing calculator. So when you come into class, that's probably the first thing you want to grab so you can get that answered.